Bismillahirrahmanirrahim. New syllabus 6 SSC2 Unit number 10 Simple Harmonic Motions and Wave. Mass spring systems, ball and bowls, and simple pendulum. Today we will discuss ball and bowl. Now we will start equilibrium and oscillation motion of ball and bowl. First of all, see in this diagram here at this condition, this is a equilibrium condition, and this condition is the extreme point in this diagram. The further way from the equilibrium and the greater the net force, because force according to the Hooke's law, F is directly proportional to X and X is the displacement. So when force is applied, then force is directly proportional to its displacement, and due to restoring force it toward the main position but move in other point at left to right. So this is according to the restoring force. This is force is also directly proportional to its displacement. In this diagram we will discuss this point is a equilibrium point and this point is further away from the equilibrium, greater the net force. Now here we can see that when the ball is displaced from the equilibrium, so net force is this direction. A force of body in this diagram, net force acting on this, and according to the Hooke's law obeys F is directly proportional to minus X. So in bowl and ball, a marble that in free to roll inside the spherical ball has an equilibrium position at the bottom of the ball where it will be rest and no net force act on it at this position at the equilibrium point. Second, if pushed away from the equilibrium, the marble weight lead to the net force toward the equilibrium position. This force is called the restoring force. Now we can explain that ball and bowl for simple harmonic motion. We can see that in this diagram, when ball is released from a restoring force, pull it back toward the mean position. Due to the inertia, in this case, ball is continued to move inside in other side. So its velocity is maximum at a mean position, where the restoring force is directed back toward the mean position. So this shows a simple harmonic motion. Now we can write that when the marble is released from the side, it does not stop at the bottom of the bowl. It rolls up and down and each side of the bowl, moving through the equilibrium position. So we can write that the repeating motion is called oscillation. So oscillation motion is produced in ball and bowl system. Now we can write that any oscillation is characterized by a period and frequency. So we can write that the oscillatory motion ball and ball. Now here in this diagram explain completely. Now in first diagram we see that release at the right side of the ball, and in this diagram we can see that at a mean position the velocity will be increases and move toward upward passing through the equilibrium position. Now due to the restoring force at the left side releasing the direction. Similarly, going on other ways from the equilibrium. One oscillation is done starting the next. Now, here in wave form, starting point at this maximum height and reach its level of x-axis. This is complete the time period in this complete one vibration. So at the position we can see in this diagram. Now we can write that the graph of oscillating motion has the form of a cosine function. So a graph or a function has the form or sine and cosine function is called a sinusoidal. Now we can write that a sinusoidal oscillation is called a simple harmonic motion in denoted by SHM. Now frequency and period. In this diagram, we can see that the sequence of beats of hertz produce approximately at the same signal. So, voltage across the chart and chest and time taken along the x-axis. See in this diagram, this is one place to another place or one node to another node complete the one revolution. So, this is the time period. Now we can write that for an oscillation, the time complete one full cycle. This is called the time period and it is denoted by T. Now, F is equal to 1 upon T and T is equal to 1 upon F. This relation shows that frequency and time period both are inversely proportional to each other or both are inverse of each other. So, the number of cycles per second is called the frequency. It is denoted by F of the oscillation. Now, the unit of frequency is hertz and it is denoted by Hs. Hd for the hertz or time period in a second and it is equal to 1 second. Now in hertz is equal to 1 third of the bowl and ball system. Thank you. Best of luck. Meet in next lesson.